Now voice is clear. Good evening to all of you. I hope my voice is clear now. Okay, so let's start discussing our subject now. First of all, this open channel flow, which I will be which I will be starting today, is a part of fluid mechanics. But as it is having very high weightage on your gate as well as AC exam and other technical exam also, this course I have designed in a separate way from fluid mechanics. Okay, so with this course what you can expect, everything I will tell you, like with this course what you can expect, how this course is going to be, everything I'm going to tell in detail. First thing, if I'm starting OCF open channel flow, it will be completed in a complete manner on YouTube only, wherever you are discussing right now. So complete course will be there. First thing. Second thing, whether you are preparing for GATE, ESC or any technical exam, even including semester exam also, this course is going to be useful for you, because I will be taking every basic concept whatever required for you to understand OCF, everything I will be taking, and irrespective of which year you belong, like first year student, second year student, third year, fourth year, even passed outs, so that is not a problem for me. Every year student can enjoy this course. Okay, that is clear for all of you. Anything else which you want to ask regarding this course? If you have any doubt, please ask in the comment section so that we can start our technical discussion. If anybody having any doubt regarding this course, you can ask me, or if all okay, then you can say all okay, or you can show the thumb sign, so then I can increase. Okay. So now, in today's class, what are the topics which we are going to study? First topic which we are going to study will be difference between pipe flow and OCF. In the second class, or in the second topic, if possible, I will be going for classification of open channel flow. Okay, so first I will be discussing this, and second I will be discussing classification of open channel flow. Now, definitely you will be asking, sir, which books we need to follow as a reference. First of all, as a reference, you can use any one book. Don't go for multiple books. That is a time wasters for you. So one book I am suggesting to all of you, which you all guys can refer comfortably, is this Flow in Open Channel by K. Subramanya, Tata McGraw-Hill publication book. This you can refer. And other than a classroom question and all, you guys are having this GATE and ESC previous year question, so that you can try for the practice part. Okay, so with this course, these two things you need to do for every topic, for every discussion. Okay, so this reference book and practice problem, that part also I have answered. I know you guys will be asking which books will be referring, so this books you can refer. Okay, now comes to the open channel flow technical discussion, introduction part. So in open channel flow, if somebody will ask you, sir, what is open channel? So first, open channel is what? It is a conduit in which liquid flows with a free surface and flow takes place due to gravity. So you guys have already seen example like river, even irrigation canal, or any even a stream which is flowing, in all those, one thing you will find common, these all are nothing but a flow which is having a free surface. Then what do you mean by free surface? So free surface is basically a interface. Here I have given also. It is basically an interface between the moving liquid and overlying fluid medium. In our case, here the moving liquid is water and the overlying medium is atmospheric air. So that interface between the moving liquid and the overlying fluid medium, that interface we are naming it as free surface. So this free surface is like an identification mark. Wherever it will be there, we can call it say open channel flow. In open channel flow, it should it must be there. Without free surface, you cannot call a flow as a open channel flow. That is very very clear in your mind. Now, as it is a free surface, the pressure will be which pressure? Throughout the motion, throughout the flow, which pressure will be carrying? The water will be carrying which pressure? I'm asking this to all of you. As it is a free surface, as it is a open channel flow, so in that case, on the top, which pressure will be carrying? Atmospheric pressure. Very good, very good. So atmospheric pressure throughout the flow, it will be taken as constant, because generally we design for a particular length of the section of the river. In a particular length of the section of the river, atmospheric pressure we have taken as constant. That does not mean that if a river, like for example a Ganga is following na, so Ganga is flowing from Himalayas to Bay of Bengal, for example. So in that case, from that flowing path at Himalayas, definitely there will be some different pressure, different atmospheric pressure. At Bay of Bengal, it will be different atmospheric pressure. But as if you are taking only 1 kilometer length, na, so in 1 kilometer length, you will not find much difference in atmospheric pressure. Is that clear? Is that point is clear? Is that point is clear? For example, what I'm telling you, for example, this section of river, if you have taken, this section is like 1 kilometer. So here and here, you will find same atmospheric pressure. But if you consider like one point is in Himalaya and one point is in Bay of Bengal, then it will be a different atmospheric pressure. You guys already know this. Is that clear? So free surface, open channel flow. What is the meaning of this? What is the general meaning of this? I think this is clear to all of you. One another point which I have written here, which you guys can see here, flow takes place due to gravity. Just like a river is always flowing due to gravity. Because see, pressure is same only. Elevation head is the only thing. That is the main reason I will say for the flow to occur. That is the reason if because of elevation difference the flow is occurring, that is nothing but because of gravity. It is like if I will be throwing some water from the 10th floor, it will be definitely go to the ground floor, na? It will definitely go to the ground floor. Now why? Because of head difference, elevation difference. So if elevation difference is the main factor for the flowing, definitely gravity forces will be in picture. And if gravity forces will be in picture, this part you will study later. That if gravity force is in picture, Froude law will be valid. Froude law will be valid. Froude law will be valid. This part you will study later in dimensional analysis chapter for fluid mechanics. But here also I can tell you that wherever the gravity forces are important, Froude law will be important, because Froude number is root under inertial force upon gravity force. This formula you will study in dimensional analysis chapter in fluid mechanics. But this part you can remember it, that Froude law will be valid. Okay, I think this is clear to all of you. Now comes to the thing, practical situation of OCF. So many example already I have given to you. You guys can note it down, those examples. First example is like sewer. So sewage flow in sewer line. irrigation canal, flow in irrigation canal, flow in irrigation canal, flow in a river, flow in a river. These all are nothing but the example of OCF. These all are nothing but the example of open channel flow. Open channel flow. These all are nothing but the example of open channel flow. Any other example? Any other example? भारत शर्मा पहले सॉम पढ़ना था, but right now I am teaching OCF ना. So first focus on this. Whichever is coming to you, first focus on this. Whenever SOM will come, that also you can study. Okay. Now the next thing is difference between OCF and pipe flow. Difference between OCF and pipe flow. Difference between OCF and pipe flow. See, whenever a new thing will come now, we always compare with the things which we have already. So why we are comparing open channel flow with the pipe flow? Because pipe flow is something which is already known to all of you. Now we are comparing OCF with pipe flow so that we get much clear picture for OCF part. We get some new points related to the OCF part. First thing is the free surface, which I already discussed with you. So write down in that part. In pipe flow means in a pipe, complete full depth is occurring. Full depth flow is occurring. That is called something as a pipe flow, where pressure dominating flow is going on. So in a pipe flow, no free surface will be there. No free surface will be there. No free surface will be there. In OCF, just now I told you, free surface will be present. Will be present. Sir, is oceanic current is an example of open channel flow? See, wherever in open, like for example surge, tidal waves, these are example of OCF only. These are example of open channel flow only. Is that clear, Ajay? Now in OCF, free surface will be present. Now this statement you guys are already knowing. Something extra which I am giving to you is regarding pressure. In OCF, throughout the flow, atmospheric pressure in OCF throughout flow, atmospheric pressure is prevailing. In pipe flow, pressure can be positive. That means can be positive or negative. What do you mean by this? What do you mean by this? Like in a pipe flow, pressure can be sometime positive, more than atmospheric pressure, positive gauge pressure, sometime negative gauge pressure, or sometime it will be less than atmospheric pressure. Like in siphon pipe, negative pressure is there, so it is less than atmospheric pressure. Sometime it will be more than atmospheric pressure. So in a pipe, both type of pressure can exist, but as in OCF, it is a complete free surface flow. So in that case, only atmospheric pressure will be prevailing. No, neither positive nor negative. Neither positive nor negative. Is that clear? So this point, this new point, or I will say a very important point, just note it down. Just note it down, my dear. Okay. Is it noted? Is it noted for everyone? Is this part is noted for everyone? First, first difference is, I think it's clear to all of you. Now the second difference we are talking about is that direction of flow. Is that direction of flow. Now listen, the directly write down the statement first. We will discuss this part, but first write down the statement. In OCF, flow takes place. In OCF, flow takes place due to potential energy gradient, potential energy gradient in pipe flow. Flow takes place due to total energy gradient. What do you mean by this? In a pipe flow, if a flow is occurring from one point to another point, that means there will be some total energy difference, total energy gradient, then only the flow is occurring. What do you mean by total energy? That means pressure head plus velocity head plus elevation head. P upon rho g plus V square upon 2g plus z. This is something we are calling as total energy. Okay. But in OCF, only the potential energy gradient is important for all of you. Now try to understand this part in a form of figure and all. So let me draw. Now this is the datum. This is the channel bottom. This is the water surface line. And this is the total energy line. As you know that here complete atmospheric pressure will be there. So this is the water surface line also. The same line we also call as hydraulic gradient line. Hydraulic gradient line. This we call as total energy line. And this is nothing but the channel bottom. This is nothing but the channel bottom. This is the depth, or you can say Z. This is the elevation part. This is the depth of flow. And this is velocity head. Okay. When you talk about pipe flow, generally we write P upon rho g. But as it is atmospheric pressure, so here P upon rho g will be nothing but the depth only. So pressure head plus elevation head. This complete will give you piezometric head. You guys are already knowing about this, that piezometric head. Those who don't know, they can note it down. Pressure head, so pressure head here is Y plus Z. This we call as piezometric head. Okay. And this water surface line is actually, you can see like this. This hydraulic gradient line is coinciding over the water surface line. So HGL means hydraulic gradient line, and hydraulic gradient line is actually representing the piezometric head. Throughout the flow, wherever the piezometric head will be there, if you join all those points, you will get hydraulic gradient line. Here specifically in open channel flow, this hydraulic gradient line is lying over the water surface only. So water surface line and HGL line are coinciding in OCF only. It is only possible in OCF, not in pipe flow. So HGL, TL, this you have understood. What about total energy line? So at every section you will be having different total energy value. Throughout the flow. If you connect all those points, you will get a line that we are calling it as TEL. So TEL, HGL, potential energy head, piezometric head, total energy head. So these concepts are clear now, because these part is already discussed in pipe flow, and those who have not completed pipe flow chapter from anywhere else, so for them I am telling these points. So what do you mean by TEL? What do you mean by HGL? What do you mean by piezometric head? Is it clear to all of you? I want reply from all of you. In my class, I want reply from all of you, so that we all will be connected in this class. So those students who are live, I want you to be active in comment section. Don't just get like blindly following everything. I want you to react in comment section also. Clear hai? Is this clear to all of you? Okay, very good. So now piezometric head you have understood, total energy head also you have understood, everything you have understood. Now in general, if I talk about, we say flow occur when there is a difference in total energy head. So let us talk about this condition. So two sections I have taken. One section is at this point, another section is at this point. Okay. So you want that's flow, sir. Flow I want. So in flow case, for flow to occur, P1 upon rho g plus, or in place of P1 upon rho g, directly I am writing y plus V1 squared upon 2g plus Z1. If you want flow from 1 to 2, definitely at 1 you will have more in total energy head, at 2 you will have less total energy head. So this will be greater compared to y2 plus V2 square upon 2g plus Z2. If you want flow to occur, here the total energy will be more compared to 2. Is that clear? Now in this some extra condition what we are adding, here. Look at here. If generally what we have seen now, like if you are dealing with 1 kilometer length of river, in a 1 kilometer length of river, you will not find much difference in the head part. You can say not head, much difference in the depth part. Will you find this thing? Like for example, if you have taken 2 kilometer or 1 kilometer stretch of the river, depth will not be changing. So we can call that as a depth is constant or depth is not varying. So if depth is not varying, in a particular stretch or in a particular section और particular length of the river भी बोल सकते हो. So if depth is not varying, my dear, Q is already constant. Discharge we have already taken constant. So can I say that even velocity will be also constant? Because V is what? V is discharge upon area. As depth is constant, Q is constant, width anywhere we are not changing. Width anywhere we are not changing. So can I say that if depth is constant, even V is also constant in that case? Can I say this? Can I say this? So if depth is constant, V is also constant. Both are constant here. So in that case, my dear, if you see here, V is equal to Q by A. 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 So if depth is not varying in a particular length of river, Q is equal to constant, V equal to constant. So if Y and velocity, these two things are constant only, so these part we can remove it now. These part we can remove it. Anywhere this is constant only. So Z1 and Z2. After that, what we are getting here? Z1 greater than Z2. What do you mean by this? If flow to occur, Z1 should be more than Z2. What do you mean by this? It is a gravity flow. It is a gravity flow. When flow is occurring only because here Z1 is more, here Z2 is less. In that case, we can call this as gravity flow. So have you understood this concept? All of you, I want reply from all of you. Have you understood this concept now? Okay, so as a note, you all can remember this thing which I am telling you. First point, HGL will always coincide with the water surface with the water surface. HGL will always coincide with the water surface. HGL will always coincide with the water surface. HGL will always coincide with the water surface. Okay. Always coincide with the water surface in open channel flow. In open channel flow. HGL will always coincide with the water surface in open channel flow. Second point, HGL may be above in different languages you write HGL may be above or below pipe axis in a pipe flow. So in a pipe flow, if you talk about, your HGL line will not be always on center, will not be always on the pipe axis. It can be more it can be above the pipe axis, or sometimes it will be below the pipe axis also. So if it is a more pressure, positive pressure, it will be above the axis. It will be negative pressure, it will be below the axis. So HGL may be above or below the pipe axis in pipe flow, but in open channel flow, HGL will be always lying over the or you can say coincide with the water surface. So this point you need to remember. This point you need to remember. This point you need to remember. Is it clear now? Is it clear now? Okay. So direction of flow, that is the second basis of your difference that we have understood. Now we are going to the third basis for this difference part. So based on velocity distribution, how this open channel flow and pipe flow are differentiated, that we are going to see in this part. Okay. So look at how the velocity distribution is there in open channel flow first. First, I will be discussing about open channel flow. So I will be discussing about open channel flow. So this is the channel section. I'm showing the velocity distribution to all of you. Here you are finding the maximum velocity. Here you are finding the maximum velocity. This is the depth part. As you are going away from the bottom line, your velocity is increasing, and according to this logic, on the top you will find the maximum velocity. But as you can see this diagram, this velocity diagram, the maximum velocity is not at the free surface. It is somewhere below the free surface. Generally this distance we have taken it as 0.05y to 0.25y. 0.05y to 0.25y. Okay. So first statement, if somebody will ask you, here you can write down, in open channel flow, or you can write like this: generally in open channel flow, flow is primarily turbulent flow, That's why you know that in a turbulent flow, the velocity distribution will be logarithmic. So generally in open channel flow, flow is primarily turbulent. That's why velocity distribution is logarithmic. Now here we are not getting, on the top we are not getting the maximum velocity. We are getting somewhere below the top. Why? Can anybody give me the reason why? According to the logic, if you go, as you are going away from the disturbances, your velocity is increasing from the bottom to the top. But with this logic, on the maximum top surface, you need to find the maximum velocity. But that we are not getting. We are getting somewhere below the free surface. So what is the reason behind it? What can be the what are the possible reason? Because of that, the maximum velocity is not at the free surface. Anybody who can help me? What is the possible reason? If somebody will ask you, what is the possible reason here? Reasons for maximum velocity maximum velocity not at the top surface. Reasons for maximum velocity not at the top surface. What are the possible reason, my dear? What is the possible reason, my dear? Anybody who can help me? Reason for maximum velocity not at the top surface. Reason for maximum velocity not at the top surface. Anybody who can help me in this case? Velocity decreases with contact of atmosphere. So, contact of atmosphere, that is one of the thing, but what is the reason? Why in atmosphere, in contact of atmosphere, the velocity decreases? Or velocity, or not always. First of all, Ajay, not always. But why atmosphere is making an impact on the velocity part? It is because of wind resistance. You need to say always the basics. Wind resistance. Second thing will be the boundary friction. Boundary friction. In whichever channel it is flowing now, the water is flowing in whichever channel, there will be some boundary friction with us. Third part will be the surface tension. You know that surface tension is nothing but, in that case, on the top, on the outer surface, we are having a layer which is completely stressed out. And that layer, the stress layer, is actually not allowing that water to flow freely. So in that case, surface tension, so these are the three possible reasons why your maximum velocity in open channel flow is not at the free surface. Is it clear till here? Is it clear till here to all of you, my dear? Clear? Have you noted? So now I will be giving you condition where you can get this 0.05y or 0.25y. This thing, something I will give it to you. So let us see the condition here. So one, we have section, we call this section as narrow but deeper section. How does it look like? Like this. Sometimes you will find drains are like depth wise they are more, but width wise they are less. So narrow but deeper section. Another section we are writing at shallow but wider section. Like Ganga is following. If Ganga is flowing in a like Patna, even Kolkata, Banaras, in these areas you will find river section is shallow but wider section, very long length. So it is like this. It is like this. In both, flow is occurring. Now, if I will ask all of you, in which case side resistance are less, or in which case side friction are less? If I will asking both the case, in which case side friction or effect are less? This is nothing but a shallow but wider section. Example, a flowing like Ganga river is flowing in a Patna or in Banaras or in Kolkata. Width will be more compared to the depth, very much high, not even a small bit, like very much high. Here you can write B is very much greater than Y. Here you can write B is lesser than Y. This condition you can follow. So in which case you will find less friction. In which case you will find less friction. Now try to understand, my dear. Try to understand, my dear. This you can understand with a basic example. For example, center velocity you are, or center flow you are focusing here. On the bank of the river, if you are giving a small disturbance like this, just touching a water on the bank of the river, do you really think it will make an impact at the center? Or do you really think it will give some impact at the center? In a river or a river like Ganga and all, if you are touching the water, if you are giving some resistance, to the water on the bank of the river, do you really think that impact will be there at the center also? No. Is that clear? So that you can understand here, side friction effect is not so great. So I can write it like this: side friction is less. Here in a narrow section, even if you give a small disturbance at the corner, or at the side, there will be some disturbance at the center of the flow also. So that means, that shows you that the side friction effect are predominant. The side friction effect are not less. It is very, very important, I will say. So here I can write side friction are more dominating. Is it clear? And because of this you can see here, if side friction effect will be more, the maximum velocity will go at much deeper section. But if side friction effect are less, this maximum line, this red line, the dotted red line is showing you the maximum velocity point, will not be much below the water surface. It will be only 0.05 y distance. Here it will be 0.25 y distance. Is it clear, my dear? Is it clear, my dear? Is it clear, my dear? Okay. Now, here only one extra point I'm telling you. One extra point which I'm telling to you. Here you will find maximum velocity here. Oh, sorry, not maximum, average velocity. 0.6 y distance. So this we have found it experimentally, you can say, or by observation, that at 0.6 y distance below the free surface, we are always measuring distance from the free surface always. So 0.6 y distance below the free surface, we are getting the average velocity. Why we are more focusing on average velocity? Because if you need to find out discharge area into velocity, so that velocity should be average velocity. So that is the reason we are finding this average velocity. So first thing you need to write down, here average velocity will occur at 0.6 y distance below the free surface. Now the thing is that if you want to find out average velocity, what you have done, that V average will be equal to V 0.65. This point is clear to all of you. But what happens if you directly go to the 0.65 distance and trying to find out the velocity, trying to measure the velocity, you will be having some error also. So in this case, what we have done, we have made a new experimental method. That's something we are calling it as 2-point observation technique. And based on that, what we are doing, look at my dear, we are finding the average velocity. So 2-point observation technique. 2-point observation technique. 2-point observation technique or method. So V will be equal to V 0.65. V average will be equal to 0.65, and that we are writing it as V at 0.2y plus V at 0.8y divided by 2. So basically, instead of taking 1 point or 1 observation, we are finding out 2 observation, and taking average of that will give you the average velocity, that is 0.65 distance. So V at 0.2y below the free surface plus V at 0.8y below the free surface, divide by 2, you will get this. So this is nothing but the experimental way to find out the average velocity. Is it clear to all of you, my dear? Is it clear to all of you, my dear? Clear? So as we are making a difference between pipe flow and OCF, so whatever we have discussed till now, whatever we have discussed, this is complete regarding the OCF. So not in detail, but at least we have need to give a small diagram for open channel flow also. Sorry, for pipe flow also. So in pipe flow, we have two options. You guys are already knowing about this. So parabolic distribution will be there for laminar flow. And this is for the turbulent flow. 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 So in laminar flow, you know this. This is something we call as parabolic distribution. And this is something we call as logarithmic distribution in a turbulent flow. These things you will discuss in pipe flow detail, but as we are making a difference between pipe flow and OCF, so I need to give the point for pipe flow also. So that is the reason I am giving in a small part. Mainly we are discussing the OCF related things. Okay. Have you noted this thing? Have you noted these things completely? Have you noted these things completely? Have you noted these things completely? Completed? Okay. So now we are going for the next basis, that is the shape of the channel. So I don't need to write much about this. You guys are already, like, you guys have already seen different type of shape in open channel flow. Like one shape is like this, parabolic, rectangular, sometime triangular shape also, sometime trapezoidal also. So different shape you have seen, sometimes circular also. So different shape you will find, different shape you will find. In pipe flow, generally you will find circular only. So one question I'm asking to all of you regarding shape, for example, depth of flow is up to this, up to this, up to this. Free surface is up to this. This is a sign for the free surface, or you can say water surface here. Tell me, out of 1, 2, 3, 4, 5, 6, 6 diagram I have shown to you. I'm giving a number to all the diagram. First, second, third, fourth, fifth, and sixth. Which one is OCF and which one is not? Which one is OCF and which one is not? Which one is OCF and which one is not? In shape of the channel, Dhrumin is telling, sir, only fifth is not. Why? Why fifth is not an open channel flow? 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 Because, sir, here free surface is not there. Ajay is telling, sir, 5 and 6 is not open channel. Why? Why not 6? In 6 we have the free surface. We have the free surface. We have the free surface. In a sewer line, complete closed flow is occurring. Complete pipe flow is closed, na? Complete pipe is closed, na? But still open channel flow is occurring, na? Because full depth flow is not going. In a sewer line, we never expect flow to be full depth flow. If full depth flow will be occurring, that means there will be no free surface. That means it will be called as a pipe flow, not as a open channel flow. If you look at the diagram fifth, full depth flow is occurring. If full depth flow will be occurring, there will be no chance of making a free surface, na? So fifth one is not an OCF. This is not an OCF. It is not an OCF. It's a full depth flow. So this is a pipe flow, not the OCF. Here it is a partial depth of flow. So there is a space for the air. Wherever the space for the air, wherever the space for the atmospheric air, definitely the free surface will be there. Definitely the free surface will be there. See, always remember, open channel flow does not mean that always the channel will be open to like closed section cannot be possible. Closed section like sewer line. I have given you the example. Sewer line, it's a closed section, na? In a sewer line, in a circular pipe, closed section, sewer is flowing. But it is flowing with a partial depth, not with the fully depth of flow. Partially depth of flow it is flowing. So in that case, we can call that as nothing but what? OCF. If it is a full depth flow, we cannot call it as OCF. That point should be very clear in your mind. I hope it is clear to you. I hope it is clear to all of you, my dear. I hope it is clear to all of you, my dear. Is it clear, my dear? In pipe flow, section will be like, generally circular we prefer. Generally circular we prefer. But that doesn't mean that always circular will be there. That does not mean that always circular will be there. But generally we prefer circular. Can anybody tell me why we always prefer circular section? Why we always prefer circular section? Can anybody tell me that? Why we always prefer circular section? Why we always prefer circular section? Why not other section? Why we always prefer circular section? Least perimeter. Very good. Very good, Durmin. Very good. Understand, my dear. Circular section is offering you minimum perimeter for a given area. If you take same area and if you plot for the same area, if you plot a square or a rectangle or a other thing like that, you will find circular section will be giving you the minimum perimeter. So what is the advantage of taking the minimum perimeter? So if it is a minimum perimeter, my dear, minimum resistance will be there. Minimum resistance will be there. And if minimum resistance will be there, more discharge can flow. More discharge can flow. If resistance is more, rate of flow will be more. Na? At the same time, if minimum perimeter is there, cost of construction will be also less. So these are the reasons which you all guys can note it down. I will not write that part. You all guys can note it down in your notes that why circular section is more preferred. First, it is efficient also. At the same time, it is economical also. Okay. So these reasons you need to mention it. Okay. So this part is clear to all of you. This part is clear to all of you, my dear. So out of 4, one more thing. In a shape of the channel, 2 different sections we have given name. Like one is we call as prismatic channel, another we call as a non-prismatic channel. So it is like, for example, na, in your village and all, you will find 2 types of canals are there. One canal will be unlined canal. And unlined means in the lower surface is not concreted or like with the bricks and all. It's completely open soil, you can say. So in that case, if it is an unlined canal, whenever the rain will come, the cross section, the slope, the shape of the canal will be changed. During rainy season, the shape, slope, size of the canal will be changed. But if you talk about line canal, in a rainy season also, the shape, size, slopes are same only. It is not changing. So that is the thing which you need to understand. So those lined canal are prismatic canal, where the shape, slope, size all are same throughout the flow in the channel, that we call as prismatic channel. And if shape, size, slope are changing along the length of the flow, we call it a non-prismatic channel. So generally whatever we are going to discuss in open channel flow, we assuming it as prismatic channel, because in non-prismatic channel nobody can give you a complete idea, na? So most of the, I will not say 99%, but 90% or whatever I am discussing, it will be for the prismatic channel, not for the non-prismatic channel. Is it clear, my dear? So in shape part only, these point you can note it down. We have divided channel on 2 part, prismatic channel, non-prismatic channel. I hope you guys have understood. Like example also, if you want, you can write it down. Lined canal or artificial canal, like man-made canal, we call it an artificial canal. For non-prismatic, it will be non-line canal, unlined canal. Unlined canal. Unlined canal. And natural canal. natural canal. Unlined canal and the natural canal. Okay. Have you noted? Have you noted these things? Unlined canal and natural canal. Lined canal and artificial canal. See, my class timing will be 8 p.m. to 9:30 p.m. Someday I will be taking up to 9:30 p.m. also. Someday I will be taking at 9 or 9:15. So this time slot you need to always book for me. That 8 p.m. and 9:30 p.m. Monday to Friday. What I can guarantee you is that if you are giving this 1.5 hour of your 24-hour day, I can assure you that 3 to 4 marks, which is possible in GATE exam or in other exam, definitely it will be more. So that I can guarantee you if you are giving this time to me. Okay. So with this 1 or 2 numerical which we can solve, next topic we'll discuss it tomorrow. That is a classification of open channel. But 1 or 2 numerical I want to discuss based on today's class. If that numerical is with me, this numerical. So every day, if possible, I will be giving you 2-3 numericals so that whatever we are discussing, someday it will be more also. But like today is a theory class basically. So here I am giving you 1 or 2 numericals which you all can try or which you all can expect in GATE exam also. Try everyone. Top width and depth of the flow is in a triangular channel where measured as 6 meter and 2 meter. That means given data we have P we have 6 meter and depth Y we have 2 meter. Measured velocity at the center line. So VC center line V 0.4y and V 1y. All these velocities are given to you. So this we have 0.8. This we have 0.6 meter per second. This we have 0.4 meter per second. Very good. Using 2-point method of velocity measurement, discharge in the channel is. So always I told you, whenever you need to find out discharge, it will be area into average velocity. Yeah, yeah, now you know that based on 2 point observation technique, average velocity is sum of, definitely it will not be the center part, 0.4y and 1 2 point. So 0.6 plus 0.4 divided by 2. So it will be 1 by 2 meter per second. So Q will be equal to area. It's a triangular section. So area will be half into base into half into width into height. So 6 into height we have 2 into 1 by 2. So 2 and 2 will cancel out. You are remaining with 3 meter cube per second. That is your final answer. So option C will be the right option. So Dhrumin, you are giving me A as answer. That is a wrong answer, bacha. One, how can you get one? How you are getting one? That's something I'm not getting. Anyone having any doubt regarding this question? Anyone having any doubt regarding this question? Okay. So another question if I will be having. Okay. So in today's class, up to this we will discuss. Tomorrow class will be for classification of open channel flow, and if time permits, I will start channel geometry. Okay, slow, and we'll study. No problem. Up to whatever we have discussed in today's class, is it clear to all of you? Up to whatever we have discussed in today's class, is it clear to all of you? Anything which you want me to suggest based on the first class, sir? We need more time to note it down, something like that. If you have any suggestions, you can give it to me now or in comment section also. And we'll meet tomorrow again. Timing will be Monday to Friday. I will not be going beyond 9:30, but less than 9:30, like up to 9:15 or up to 9, it will be possible on Sunday. So that is something which I want to tell you. Anything, any even a small doubt you have, you can ask me. As I said, this class will be complete discussion. Sir, is it a crash course? No, it is not a crash course. If this could have been a crash course, na, this point I have completed within 15 minutes. More than 15 minutes, I will not be given to this. Okay, so I'm taking this class in such a way that this class will be useful for you for ESE also, for GATE also, for semester exam also, for every exam you can use it. Okay. So it is not a crash course. I think on GATE Wallah MEC, that Hindi channel, I have taken the OCF crash course, na. So that crash course got completed in 6 to 7 days. I think 7 days class I have taken. Here the classes will be 20 classes, 25 classes will be there. Okay. Okay. So good night. Take care. We'll meet tomorrow. Bye bye.